First one, I need to factor completely.
Okay.
It's 10d to the power of 6 minus 6d squared.
Okay. Very first thing you should always look for when you're factoring is there a greatest common factor?
Yeah.
Always check that first. Is there a greatest common factor here?
No.
Well, is there a number that can divide evenly into both of these terms?
Yeah.
What?
2.
Okay, so there is a greatest common factor of at least 2.
Yeah.
How about a variable? Is there a variable that can divide into both terms evenly?
Yes.
What is it? D squared.
Yes.
Notice, and then what's going to be left is what I get when I divide both terms by my factor.
Yeah.
So what's the first thing?
The first one, 5d to the power of 3.
4.
4.
Remember, you add the exponents when you're multiplying.
Oh yeah. 5d4 and then 3d squared.
What's the answer to that right there?
Yeah. Is that 3?
Just 3. The d squareds
Yeah.
cancel. I got 6 over 2. Okay.
Yeah.
So now what I highly recommend whenever you're doing factoring is as you do it, check it. Don't wait till the end. What I mean by that is when you come up with this 5d to the 4th, immediately multiply it by 2d squared to make sure you get 10d to the 6th.
Okay.
As you're doing these problems, step by step, you should always be checking. Always be checking to make sure that that times that is 6d squared. And it is.
Okay.
That way, by the time you get to the end of the problem, you won't have to go back and check it every single part of it. You'll know that you got it right. Now, can I factor that further? Not really.
Yeah.
This doesn't factor by anything that you've been taught yet.
Yeah.
So this would be the answer they're looking for.
Alright.
But there's 3 things that you check for. One is, the very first is always greatest common factor.
Yeah.
Very second is difference of perfect squares. And the third method is the standard quadratic method. In other words, if I had x squared minus 7x plus 10, there's no greatest common factor. It's not difference of perfect squares, but it's a standard quadratic. And by that I mean it has an x squared term, has an x term, and it has a number. Now, whenever that's the case, you're never going to find, well, not never, but you're almost never going to find there's not going to be a greatest common factor when you have all 3 of these terms.
Yeah.
I mean, there might be a greatest common factor if that was a 2, that's a 14, and that's a 20. Now I can take out 2, but it leaves behind what I had before. And so the problem still becomes factoring the quadratic. And if you can figure out how to factor these kind of quadratics where the coefficient of the x squared is 1,
Yeah.
you're going to be in great shape.
Yeah.
Okay? even if you have difficulty with the harder ones. I'm just telling you that you will rarely have to do a hard one. By a hard one, I mean if it was 2x squared minus 7x minus 15, that's a hard one because I cannot take out a greatest common factor. And if I try to factor it like a quadratic, I get 2x times x, and then it's at least 2 degrees of difficulty harder than if I was trying to factor something that had a 1 there. Okay? And I would say that you're going to be confronted, 90% of the factoring you have to do of quadratics is going to be of that format, where the x squared has a 1 as a coefficient, meaning that when you split it up, it becomes x times x. Those are pretty easy to factor. They get a lot more difficult when there's a number there. If that's a 5, it's difficult. If it's a 6, it's even more difficult because now there's 2 different ways to split that up. I could make it 3x times 2x. I could also make it 6x times 1x. So the larger that coefficient is, the harder it is to factor. Now always try to do greatest common factor, because sometimes they'll give you a problem where they give you a large coefficient, but you can actually factor out the whole thing, leaving behind a simple quadratic. By simple, I mean has a coefficient of 1. Okay? So that's really the secret. That's the secret of factoring, is do these 3 techniques in order. Check for greatest common factor, check for difference of perfect squares, and then check for if it's a normal quadratic. So what else you got?
I have another one of those. M to the power of 4 minus 16.
Is that number 1? Can we do greatest common factor?
There are none.
But difference of perfect squares.
Okay.
Is this a perfect square? Is this a perfect square?
Oh, yes, it is.
And they are being subtracted, which means it is difference of perfect squares.
Yeah.
Now, let's make sure you know how to do difference of perfect squares. How's that factor?
A times.
Always A minus B. Start there.
Yeah.
The other side is just a conjugate. You don't need to think about the other side. In other words, once you've figured that out, the other side is always the conjugate, A plus B. Okay? So, in this problem, how's it going to factor? What's the first term going to be? So that's all we need to figure out is the first term.
Okay. Would it be M minus 4?
Well, you got to take the square root of that, gives you A, and the square root of that gives you B. What's the square root of M to the 4th?
M squared.
So that goes there. Always do the minus as the first one. It's the square root of 16.
8. No, yeah, 4.
Which means this part is M squared plus 4. I don't need to even think about it.
Okay.
Now, it's not fully factored because that factors again. Notice that that's also still the difference of perfect squares.
Okay.
So what's M squared minus 4 factor into?
M plus 2.
Start with the negative. And there's a reason why I say that.
Alright.
Okay? Because there's also a formula for difference of perfect cubes. there's also a formula for sum of perfect cubes. And when it gets time to memorize those, there's a pattern you can use. And that pattern is always making the first term the same sign as that. So don't say it's m plus 2 times m minus 2, even though that's the same answer. It's just it's going to be easier for you to learn it and memorize it if you always start out with the sign that's the same as what the problem is. Now, there is no sum of perfect squares. So m squared plus 4 does not factor. There is difference of perfect squares, and there is difference of perfect cubes, and there is the sum of perfect cubes. They haven't taught those to you yet, but when you have an odd exponent, you can factor sums. When you have an even exponent, you can't. In other words, m squared is an even exponent, and it's plus 4. That's the sum of perfect squares. But sum of perfect squares does not factor. If you had sum of perfect cubes, in other words, if you had m cubed plus 8, that actually does factor because m cubed is a perfect cube and 8 is a perfect cube. So it's only the sum of even numbers that does not factor. Odd ones do. In other words, m to the 5th would, m to the 7th would, so forth and so on. But when you're looking at difference of perfect squares, it only applies to the difference of perfect squares, not the sum. So we can't do anything with that, but we've got it down to its 3 major factors. All right? Hold on a second. I want to leave those 3 things up there for the moment, because that's the order you always want to go. You want to look for greatest common factor. If you don't find any of those, look for difference of perfect squares. If you don't find any of those, then it's almost certainly a standard quadratic. Okay, what else?
I have 98 minus 2z squared.
Like that?
Yeah.
Okay. Step 1, is there a greatest common factor?
No.
Well, hold on. Remember what greatest common factor is. Is there any number that divides into both of these things evenly?
Yeah.
2.
Yeah.
So I can take a 2 out, leaving behind what? It's half of 98.
Yeah, which is 49 there.
Okay. Now notice what I have. This part is difference of perfect squares. How do you know? Because 49 is a perfect square number and z squared is a perfect square number. So factor that. So the whole thing factors into what? Start with the square root of that.
I have 49.
What's the square root of 49?
Oh, wait, no. Put 7 there.
Always put the minus as the first. What's the square root of z squared?
Z.
What's the second term?
1 plus Z.
7 plus z.
Yeah.
There's your answer. In other words, always go in this order, and this will never fail you.
Alright. Another one?
Yeah, what else?
Alright. We have a qx to the power of 9 minus 4x to the power of 6 plus 10x cubed.
It's the first step,
Great concept here.
which is do first the number and then the variable.
2x cubed there.
Good. Leaving behind what?
2x to the power of 3.
Hold on. Let's assume that you're right. Now, always be checking. Is that times that equal to that?
No.
Okay, that's not the right answer then. Whatever we write here has to multiply to that to give you that.
Okay.
What's it going to be? And the easy way to do it is just divide that by your factor.
Yeah.
What does that equal to?
I do not know.
Subtract the exponents. When you're doing division, subtract the exponents. So x to the 6th. And again, always be checking. Multiply that by that. You add the exponents, you get 2x to the 9th, which is what you started with. That means we did it right. Okay. Next term.
We have 5x.
Hold on. We're dividing 4x to the 6th by 2x cubed.
Yeah.
What's that equal to? If I divide that by 2x cubed.
You want to say 2x cubed.
Good. Now finally divide that by 2x cubed.
And it's 5x.
Nope.
Okay, just 5.
Just 5 plus 5. You do need to specify whether it's plus or minus. Plus is never assumed if it's part of a polynomial. In other words, if I just wrote that, that has no meaning.
Yeah.
So you've got to put the plus or minus, because that 5 is part of a polynomial, and it either needs to be added or subtracted. So you can't leave off the plus sign in this instance.
Okay.
Okay? Now, question is, does this factor further?
No.
You're right, it doesn't. At least not without applying the quadratic. I should list a fourth method up here, which is if all of these first three fail, then you have the quadratic formula.
Okay.
And that's really the order to go in. In other words, you try to factor it like a normal quadratic would, but if you can't, and I can't here, then I could apply the quadratic formula. Now, the quadratic formula can only be applied to quadratics. Well, this doesn't look like a quadratic, but in reality it really is. In other words, the only thing a quadratic is for this term to be the square of that term. If it is, then it can be treated like a quadratic. But regardless, we wouldn't be able to factor this. We would have to use the quadratic formula, and I'm sure they don't expect you to do that here. Have you been taught the quadratic formula?
No.
Okay. Well, then let's erase that from an option. We'll assume that every one you get is going to be solvable by this. And notice that as I did this, that times that is 2x to the 9th, that times that is 4x to the 6th, and that times that is 10x to the 3rd. So I'm always checking whether I do it at the end or whether I do it as I go along. I prefer doing it as I go along because sometimes the end can be, you know, there's 12 steps in this thing. Then you got to go back and check all 12 steps. Well, it's easier if you check each one as you go along.
Okay. Next one.
Uh-huh.
Alright. It is 7k minus 14h power now.
Well, I'm not hearing you good enough.
Minus 7k minus 14h to the power of 9.
Like that?
Yes.
Okay. First step.
This comes back in.
Is there one?
No.
When you're trying to determine the greatest common factor, differentiate between numbers and variables. Start with the numbers. Is there a greatest common factor between 7 and 14?
Yes.
Okay, let's take it out.
Alright.
What's left?
Well, k is left. And then 7h to the power of 9.
That's 7. 7 times 7 is 49.
Oh, 2h to the power of 9.
Okay, always be checking. That's 7k. That's 14h to the 9th.
Okay.
Okay. Now, they're giving you some strange problems. Can I factor that?
No.
No, there's no greatest common factor. Difference of perfect squares does not apply because k is not a perfect square and 2h to the 9th is not a perfect square. So I can't use dopes. And that's not really a quadratic. That's a 9th degree polynomial. So I can't do much with this.
Yeah.
And that's going to be your answer.
Alright.
Or sometimes the only thing you can pull out is a number. Sometimes you can pull a number and a variable. But treat them separately. Do the number first and then do the variable.
Okay. Next.
Yeah.
There is 20v squared minus 45.
Minus 45?
Yeah.
Okay, tell me what to do.
Well, the greatest common factor is probably
Good. Leaving.
what is that? 4v squared.
All right. I just realized you said Z, but we'll use B. Doesn't matter. Minus what?
Minus 9.
Okay. Now, after we've pulled out the greatest common factor, continue to check and see if dopes applies.
Okay.
Does it?
Yes.
It does. That is a perfect square, and that is a perfect square, and they're being subtracted, so we have the difference of perfect squares.
Yep.
Now, to do it easily is all you need to do. Don't need to worry about that term. If we can get this first term, we got the answer. And the first term, the square root of that is what?
2b.
Square root of this is what?
3.
Always put the negative as the first one. What's the second part? That's the part you don't have to think any about at all. You don't have to do any checking. You don't have to do anything. As long as you've done your first step correct, which is find the square root of that first term, square root of the second term, then this is automatic, and I don't even bother to check at that point. That's my answer. So in this problem, we had to factor out a greatest common factor in order to be left with difference of perfect squares. And that's very common. They'll frequently give you problems like this, that you have to do 1 and 2. So far, they haven't given you any standard quadratics to factor.
Yeah.
I'm not sure why, but go ahead. Maybe it'll come with your harder problems here.
I have one more actually.
Okay.
It is b squared minus 16b plus 60.
Okay. Is there a greatest common factor?
No.
Is it difference of perfect squares?
Yeah.
That means it's going to be a quadratic, the standard.
Yeah.
The standard quadratic has a squared term, has an unsquared term, and it has a number.
Yes.
Okay?
Okay.
Now, this is what you can use a lot of practice on, and I don't mean you, I mean everybody. It's just you don't get, everybody can use practice on factoring, and it's a huge skill that you need to master. You need to know how to factor standard quadratics. Now, the way I teach people is a little different than perhaps the way you've learned in class. They may give you a diamond method or a California method or all kinds of methods to factor. Basically, what we're doing is multiplication in reverse, right? In other words, if I had the two linear factors here and multiplied them together, I would FOIL them. Well, instead, they're giving me the answer, and they want the two factors. So the first step is what?
We need to split it down.
Split that up. It's always the first step. That gets split up as B and B.
Yeah.
In other words, if I'm going to FOIL this final answer back together again, the first thing I'm going to do is multiply B times B to get B squared. Okay? So that first step is very easy, very common, and always going to be the case. Now, second step, determine both signs. In other words, do I have minus plus? Do I have plus minus? Do I have minus minus? Or do I have plus plus? You can determine all of that in one step.
Okay.
How can I produce a plus 60? Can my signs be opposite? No, they can't be. If they were opposite, that would have to be a negative number.
Yeah.
So the fact that this is a positive 60 tells me my signs have to be either minus minus or plus plus.
Hold on, my mom's calling me. Can you hold for a second?
Sure.
Alright, we're good.
Okay. So, this is very important to figure out how to do this in a very simple way. Trust me, this is the simplest way anybody will ever teach you how to do these.
Okay.
First step, split up the B's. Second step, determine both signs. Well, I know both signs have to be the same. They could be minus minus or they could be plus plus. Either one will produce a plus.
Yeah.
I look to the sign on the middle term to determine which. The sign on the middle term is negative, therefore it has to be minus minus.
Okay.
Now, the third step, factors of 60 that add to the number 16. It's as simple as that. Factors of 60 that add to 16. What would that be?
16.
Yeah, I don't know what you said. I couldn't hear you. But let's figure out, let's go through the technique of factoring a number.
I just take the 10.
It is, but I still want to go through this. Okay, I start with the number and 1. If I can cut the number in half, I do so and double the other one. So 30 and 2 are also factors. If I can cut the number in half, I do so. I can cut 30 in half, double this, gives you 4.
Yeah.
Now I can't cut 15 in half anymore, but I can cut it in thirds. So I can make that 5, triple that, that's 12.
Okay.
Now notice I can go the other way. I can cut this one in half, 12, and double this.
Okay.
Boom, I just found my two factors, 10 and 6.
Yeah.
Now, you were able to do it without going through this process, but factoring a number can be a difficult process to do. I mean, and your calculator isn't going to help at all. So you really need to know how to factor a number. For example, let me just do a different one. Factor 50.
I prefer using a factor tree.
Well, bear with me here. This is the same as a factor tree. Trust me. Okay? Try cutting that in half, can you?
No.
Well, yes, you can. 50 is divisible. All even numbers are divisible by 2. There's no even number that isn't divisible by 2. So what's half of 50?
25.
Which means I have to double this. Now, I cannot take half of 25. I can't take a third of 25. And if I couldn't take half of it, I can't take a fourth of it either. Can I take a fifth of 25?
Yes.
5. Which means I got to multiply 2 by 5. There are all of the factors of 50.
Okay.
In other words, I can no longer break down that 5. I could break down the 10 by making it 5, but it's still going to be 5 times 10. In other words, I haven't changed the factors. You only keep going if you can find new factors. Okay, in other words, there's no reason to write 2 new factors that are the same as what you already have. And I can't cut 10 by a third. I can't cut it. I could cut it by a fifth, but that doesn't do me any good. It gives me back to those 2 factors. So this is a great way to factor. First, try to cut the biggest number in half. If you can't do that, try to cut it in a third. If you can't do that, try to cut it in a fifth. If you can't do that, try to cut it in sevenths. Notice what each of these is. They're prime numbers. I didn't try a fourth because if I can't cut it in half, I can't cut it in fourths. And if I can't cut it in thirds, I can't cut it in sixths. So you go through the prime numbers is what you attempt. The next one would be try to cut it in elevenths. It's the next prime number. Okay? And that'll always work for you.
Okay.
What else you got?
Well, that's all I have.
Okay. Let me give you one more quadratic since you only gave me one. I'm going to give you an easy one. Well, I'll give you two.
Okay.
Factor that. Notice, no greatest common factor, not difference of perfect squares.
Okay.
What's first step?
First step is to factor, so we have x on both sides.
Okay. Second step?
Find the factors for 7x.
No. Everybody wants to skip the second step. I cannot tell you how many of my students, when I teach this, they always want to go to the third step immediately.
Yeah.
The second step is determine both signs.
Okay.
I can do that by the information given to me. First of all, there's only one way to produce a plus 10, and that's if both signs are the same. So I know it's either minus minus or plus plus. What is it?
Plus.
Yeah, because the sign on the middle term is plus. So it's definitely plus plus. Now go to your third step. Factors of 10 that add to the number 7.
5 and 2.
Good. So that is a 3-step problem, and that's it. I'll give you one more. This is slightly harder because I have a negative sign in front of the constant. First step's the same. Now, what are both signs?
They're both minus.
No. 2 minus signs would produce a plus.
Oh.
Remember how you get that term. That's the last step of FOIL. In other words, you get this number by multiplying the two last numbers together. So the only way you can possibly get a negative is if both signs are opposite. So it's either plus minus or minus plus. And it turns out that it doesn't matter which I do. So I'll go with plus minus. Now the third rule is slightly different. I want factors of 10, but instead of adding to this number, they have to subtract because of that negative sign to 3. Well, factors of 10 that subtract to 3 are still 5 and 2.
Yeah.
And now I have to know where to put the 5 and where to put the 2. Always put the larger of your factors with the sign of the middle term. The sign of the middle term is plus. The 5 goes there. The 2 goes there. All right, Nick, I will let you go.
All right, that's good.
Talk to you next Wednesday.